Here we are in chapter 6 again. Section 2, we're going to talk about linear equations in one variable, usually x, but you can choose any letter you want to, and also about proportions, which are special equations. 5 things we're going to hit: linear equations, ones that have fractions in them. We're going to make that easy though. Solve proportions, which are easy equations. In fact, it's got a couple of shortcuts too. Solve problems using proportions, real easy as long as you keep organized. And then finally, some equations don't have a solution, and some of them have infinite many. So we'll take a quick look at that at the end. So let's check here, make sure my pen is working. There we go. Okay, let's try that again. Okay, let's roll here. Linear equations. So first of all, I'm going to clear this. There we go. Linear equations. Well, this is what they look like. Notice the important thing is you got a single x. Could be a y or a z or something else. A single x. And the a and b are just placeholders for some real numbers. For example, we might write, this pen is not working for some reason. Okay, I'm going to have to use the mouse. All right. One more time. All right. It might look a little bit weird, might feel a little bit weird, but I'm going to use the mouse because my pen doesn't seem to want to work. Here we go. Linear equations in one variable and proportions. Those are the 5 sections we're going to go, and here we go. All right, linear equations, what do they look like? Well, this is what they look like right here. The important thing to note is that there's only one variable, that's the x. The a and the b that you see here are actual placeholders for real numbers. For example, this might be 3x plus 7 equals 0. All right? Put in what numbers you like in particular examples. And of course, this is important too, but usually you don't have to be concerned about that. If a were 0, you'd have 7 equals 0 or 6 equals 6. The whole thing just falls apart. You're not really doing algebra. When you solve equation, what you're doing is you're finding out what x works if you put it in for all values of x. And those x's that work, making it a true statement, are called solutions or roots. They're the exact same thing, just different words. Synonyms, if you want to use the English term. Equivalent equations, not complicated. They have the same solution set. So the x that works over here is the same x or x's that work over there. That's what equivalent equations are. Now I've got some properties that allow us to solve these equations. The important thing about this first one, and there we go, the addition property of equality. Very simply, it means you add the same thing to both sides and you get an equivalent equation. In other words, you're just talking about the same x that solves the equation that you started with as the one that you have currently. So this and this are equivalent equations, because if you subtract c on both sides, I'm using my mouse, so hang in there with me, you end up with a equals b. They're equivalent equations because you talk about the same x's. The same thing works for multiplication. If you multiply both sides of the equation, it doesn't change the solution set. You still have equivalent equations. This one's a little bit off here. A equals b. And over here we have AC equals BC. In other words, we'll just multiply both sides by C and you have the same solution set or equivalent equations. There we go, that's a better one. Next, you can look through these. These gives you some examples of how we actually work with these. Here we go. So here's an equation you might start with. You want x all by itself, so you say x equals blah, blah, blah. Well, if you add 3 to both sides, then add 3 here, the 3's are going to disappear. And of course, you have to add the same thing to both sides. Add 3 to that side, you end up with x equals 11. And this is what the solution set looks like. All it means is use braces, and whatever solutions you get or roots you get for your equation, you put them inside the braces. That's what a solution set is. Very simple. Second example over here. Here, instead of adding something to both sides, we subtract something from both sides. So subtract 7 here. And the goal is you want to get that x all by itself. Make sure you do the same thing on both sides. And there's the operation in a horizontal format. And we found out x equals -22. No other ones? Only the 22, -22. The third one is here. Here we've got 6x equals 30. Now remember, this might be part of the solution of an equation. You work to a certain point, you get 6x equals 30. How do you get from there to x equals? Well, divide both sides by 6, or you can multiply both sides by 1/6 to the same operation as far as results. So here's what you actually do, and there's what you get. 5 is the only one we end up with, so this becomes our solution set. All the solutions are listed inside the braces. And number 4, instead of 6 times x, you've got x divided by 5, so you do the opposite thing. You multiply both sides by 5. And there we are, multiplying by 5 here and here. And you end up with a solution set that has 45 in it. Okay, solving a linear equation. Let's check again and see if this thing is going to work. Apparently not. Okay, sorry for rambling on there. I was just checking to see if I tablet pen was going to work. Well, it isn't, so I'm going to continue using the mouse. So here are some steps in case you like steps. These can keep you straight. Once you actually get some familiarity with this and get some practice with this, you actually forget this. First thing, notice, remove the grouping symbols. So look for the parentheses, or brackets, or braces. And also, combine like terms. Remember what those are. Those are the terms that have the variable part the same. Collect all the variable terms on one side. In other words, put all the x's here and all the numbers here. So you're isolating the variable. It'll be on one side, and you solve it. Once you solve it, check it in the original equation. Now this is very important. Don't check it in one of the intermediate equations that you created, the equivalent equations. Check it in the original. Go back to the beginning. If you're working a word problem, for example, go back to the word problem with that solution and see if it works and if it makes sense. If you're looking for how many slices of pizza you want to eat and you end up with a -3, well, that's not a solution because you can't eat a -3 slices of pizza. Obvious, but you need to keep that in mind. So here's an example, and remember I'm using the mouse, so bear with me on this. So 2 times x minus 4, use the distributor property. You're going to multiply times the x and times the 4. So you have 2x minus 2 times 4 is 8, minus 5x, you're still on the left side, and then comes the equal, and the -5 is all by itself, so we don't do anything with it right now. So we took care of the parentheses here, or the grouping symbols, with the distributor property. Next, take a look at the left-hand side. Notice that we've got an x term here and an x term there. So we can add those together. Adding those together, we get a -3x. We've still got the -8. And we've still got the -5. Next, the x's are all on the left side. That's good. But we need to get rid of this -8. So we'll add 8 here. To make sure we still have equality here, we'll have to add 8 over here. That gives us -3x because the 8's are gone. And on this side, we'll combine those two. Remember, the 8 is bigger, so we subtract these two. Different signs, subtract. Get 3. Because the 8 is bigger, it gets this sign. So get -3x equals +3. Now, divide by the -3, or multiply by -1/3. Same difference. And what we have is x equals -1. So for a solution set, we put the -1 inside the braces. That's the only solution we have this time. And we're almost done except for one thing. We need to check and see whether this actually works. If we all did our algebra perfectly and never made a mistake, we wouldn't need this, but this is the safe thing to do. So we're going to go back to the original. Always go back to the original. X minus 4 minus 5x equals -5. Always start with the original. Good. Next, we're going to put that -1 that we found into the x, because x is supposed to be a -1. So we'll have 2, -1 minus 4 minus 5. Now remember, the x is a -1 equals -5. There's your original equation with the solution put inside. Now, we do inside the parentheses first, so we need to take a -1 minus 4 first. So we have 2 times -5. And if we look over here, we'll just copy that. Eventually you'll probably do a couple of things at a time, but take it nice and easy. Next, we have some multiplication to do. That's next. So 2 times -5 is -10. -5 times -1 is +5 equals -5. On the left side, we've got two numbers. Add or subtract them from left to right. That gives us -5 equals -5. Perfect. So this checks out, and this is the correct answer. Check with me in class. I'll give you a tip on how to use your calculator. So the text instrument ones anyway, show you how you can do this and check it out. Spoiler alert, you would take the solution you just found, you're going to store it in your calculator's X mailbox, and then you're going to write the left-hand side in your calculator, hit enter, and you should end up with -5, because your calculator is going to get to the x and it'll say, oh, that's a -1. It'll get to this x and say, oh, that's a -1, and it should end up with a -5. An easy way to check. Now, we're going to talk about sense of humor and depression. This is a study that was done. Oops, sorry. There we go. This is a study that was done that found out that, notice that this represents how good your sense of humor is, and this represents how deep your depression might be for certain situations. Gee, things wants to jump around all over. So you can see that those with the low humor group, those are these. The tougher things get, the more depressed they are. With the high humor group, the ones that find things funny easily, even when things get really tough, their depression level doesn't go anywhere nearly as high. So, if there's any way you can think of it, try to see the humor in things on a daily basis. Now we're going to take a look at the high humor group, because we've got a question right here. We want the intensity of a negative life event that was on the negative side there. Of a negative life event anywhere from 1 to 10 in that picture you saw previously, with an average level of depression. What would be the intensity of the negative life event if the depression ends up like this, and it's for the high humor group? So the high humor group means we're talking about this formula over here. So all you need to do is take this equation. So this equation, we'll just copy it. D equals 1/9 x plus 26/9. And what we're going to do is we're going to put the 7/2 in for the depression level. And of course the depression level is right there, so put that in. So you've got 7/2, that's the depression level, equals. And we're going to find out for the high humor group, what is the intensity of a negative life event? So we've got 1/9 x, just copy what we've got on the right, plus 26/9. All right, what do we do with this? Oh no, we've got fractions. The bane of math students. However, here's a trick for you. And the trick is very simply this: the lowest common denominator. So you look back here at the equation. What is the lowest common denominator? Well, the denominators are 2, 9, and 9. So the least common denominator would be an 18. Now where does it fit in? Well, very nicely. You're going to use this 18, the lowest common denominator, and you're going to multiply all the way through by 18. So 18 times 7/2 plus equals, and 18 times every term, 1/9 x, close that, 18 times the next term, 18, and you can think of this as 18/1, since we're working with fractions anyway. Excuse me. 18 times 26/9. And you might be saying to yourself, this looks more complicated than what I started with. Only temporarily. Because if we look back over here, I'm going to change the ink color to black temporarily. Now over here on the left hand side, the 18 and the 2 can be reduced. 2 into this is a 1, 2 into this is 9. So all we have on the left side is 9 times 7 is 63 equals. Now, we haven't finished yet, but notice what happened. When I multiplied by the least common denominator, I didn't have any fractions anymore. So we're going to keep on going. 9 into this is 1, 9 into this is a 2. So we've got 2. These 1s we can pretty much ignore. So we basically got 2x. No fractions, that's the deal. And over here, 9 into this is 1, 9 into this is 2. 2 times 26 is 52. Now I'm going to move up here so I have a little bit more room. And what I'm also going to do is I'm going to switch these two sides. You're allowed to do that. So I'm going to make this 2x plus 52 equals 63. I'm more comfortable working with x's on the left-hand side. I'm not sure whether you are, but if that is something that appeals to your comfort, go ahead and do it just like I do it. All right, next. I've got all the x's are on the left side. That's good, but I've got a number next to the x. So I need to subtract 52 from both sides. That way it'll still be equal. I'll still have an equivalent equation. Still talking about the same solution x. Now, what does that leave me with? Well, these cancel out the 52s. I'll end up with just 2x over here. And once I subtract those, because remember I'm subtracting because the signs are different, so I end up with 11, positive 11 because the 63 is bigger. And then down here I've got 2x equals 11. How do I get rid of the 2? Divide by 2. So I have 2x divided by 2. And for it to be equal, I have to do the same thing to the other side. And my x is 11 halves, or 5 1/2. Now we might want to go back. What does the 5 1/2 represent? It represents the intensity of a negative life event that produces depression of 7 halves. So you would want to write this answer as the intensity of a life event is 5 1/2. That will cause a depression level on the average of 7 halves. For the high humor group, all of that needs to be in there. Imagine you're writing an email to someone and they sent this question. You need an answer. You're doing it by email or by letter. Unlikely. X equals 5 halves is not an answer to a word problem. Keep that in mind. All right, we've got another one to play here with. Notice this one has parentheses on the right-hand side, so we need to multiply through using the distributive property. So leave the left-hand side alone. It looks okay for the time being. On the left-hand side, multiply both of these by 2. So 2 times x is 2x, and 2 times 4 is 8. Now what's next? There we go. What's next is you want to get all the x's on one side, all the numbers on the other side. So let's get rid of this 2x. So we'll subtract 2x here, subtract 2x there. What do we have so far? Well, just 6 over here, and over here we have 8. And part of you says, what in the dickens is going on? Well, it's important to remember, what does this really say? I'm going to check back here with the red. There we go. This statement over here says, this is a statement that if you pick the right x, this is going to be a true statement. All of these are saying the same thing. If you pick the right x, then 6 equals 8. Well, there is no x that's going to make that true. So we don't have an x that's going to work for this. So what's the solution set? Remember, the solution set looks like this. If there aren't any x's, there's your solution set. If you want to, you can write the solution set like this. Remember, it represents the same thing. So if you do all the right things, all the right steps on the equation, and you end up something that cannot possibly be true, then your solution set is the empty set. There are no solutions. No solutions. And last of all, we've gotten to the end here. Let's work on this one. Notice again, we've got some parentheses, so we're going to use the distributor property. So we've got the 4x plus 6 on the left. Distributing, we've got 6 times x is 6x. And 6 times 1 is 6. And minus the 2x that was there to begin with. All right, what do we have to do now? Well, on the right-hand side, we've got x terms both places, or on the same side. So we're going to combine those two for the next step. So we'll just bring down this 4x plus 6 equals. So 6x minus 2x, that's 4x. We've still got the plus 6 there. And look at that. We've got the same thing on both sides. It's not going to matter what our x is. If we take it a little bit further, just because we can subtract 6 here, subtract 6 there. Remember, we double check, did I do everything right? Yes. So what would that give us? 4x equals 4x. If we followed our instructions as before, we'll divide both sides by 4, so we can get just x. And what do I get? X equals x, which we could have figured out up here because it looked like it was exactly the same. How could x work? Well, actually, it means no matter what you put in for x, this is going to be true regardless, which means this will always be true, this will always be true, and that will always be true no matter what our x is. So what does the solution look like? The solution set. The solution set has all real numbers. If you don't quite believe me, put any number at all in for x. Here's this trick I told you about. Put negative 17 in your TI-84. Store it in x. Next, type in 4x plus 6 and see what you get. On the right-hand side over here. Now on your calculator, type in 6 parentheses x plus 1 minus 2x and see what you get. What you'll find is no matter what you put in for x, your results are going to be exactly the same all the time. So your solution set is a set of all real numbers. And here it is in set builder notation. I put it in a slightly different form. Mostly because I wanted to do it a little bit faster because I can only use my mouse right now. And that's our solution set. All real numbers. Well, we finished section 2. I hope you picked up a few tips here and you can work your exercises. Until next time, take care of yourself, and I'll see you in section 3.